Most of us have dreamt of traveling throughout the stars, or at least visiting other planets within our solar system. As of now, the capability to do so remains just out of reach, but we would unquestionably be moving away from the safety and comfort of our own planet. Could we one day travel to other planets? Most probable. What about other stars? Perhaps one day. What about to the end of the universe? That is a matter that does not need any science fiction solutions, or at least nothing beyond the physics we know. Hello guys, and welcome back to our channel. In today's video, we will be discussing space travel and how far we can advance in our current technology. We will also take a look at the future technology we will need to journey far distances throughout space. But before we get started, please take a moment to subscribe to our channel and hit that bell icon so you never miss another weekly video update from us. That said, let's get started. Our technology we have today in space exploration is great, but it does have its limits. American astronauts James Lovell, Fred Hayes, and John Swigert are the three humans who have flown the farthest from Earth as of 2021. During the Apollo 13 mission in 1970, they were 400,171 kilometers, or 248,655 miles, from the surface of the Earth when they traveled beyond our moon. There are now even better rockets in production, and crewed spacecraft are being developed to transport humans back to the moon and beyond, but there are other worries that come with this. The greater their distance from Earth, the increase in cosmic radiation astronauts are exposed to. A large portion of this is shielded by our planet's powerful magnetic field. But what is keeping you safe as you move further into space? Solutions to this have been studied by researchers. Fungi found living in Chernobyl can thrive on radiation and might be utilized as a biological shielding system on spaceships and human homes in space in the future. Obviously, as we continue to explore deep into space, we will need some type of protection for ourselves from this harmful radiation. In the cosmos, there is an empty, chilly, and unmarked frontier. These journeys would take months, if not years, and there has been much discussion about one-way voyages. In general, the rest of the solar system is an incredibly dangerous place that may quickly kill us if we are not prepared. We may be able to get to other places, but this does not mean we will be able to flourish in those environments. If you feel that all the obstacles of local space travel can be overcome, you might wish to shift your attention to the stars. Is it possible for humans to travel to another star system? Consider Proxima Centauri b, the nearest star to our Sun. It would take a little over 4 years to travel there at the speed of light. However, with our current fastest spacecraft, it would take over 8,400 years to reach without even slowing down. There have been other suggestions to deploy robotic explorers there. Miniature rockets could arrive in just a few decades, while the bigger, nuclear-powered vessels could arrive in a few hundred years. While these are thrilling ideas for space exploration, they are not appropriate for human space travel, as they are much beyond our lifespans. A generational ship could be a solution to this issue. For this, the first generation would leave our planet, and their successors would go to a distant star. Obviously, we should be perplexed as to why someone would go on this path. However, it is also necessary to address the ethical and psychological situation that the interplanetary middle children would be in. Would they want to keep moving in the direction of something they may never be able to see? In concept, we are capable of producing faster rockets to reach other stars far away in other galaxies. A relativistic rocket would be required for this. This would allow a small group of individuals to travel great distances while using a little more than our existing grasp of physics. We would need a rocket that can travel at 9.81 meters per second squared. That is the typical Earth normal pull, so individuals in the spaceship would feel as though they were standing on our planet's surface. Such an acceleration would swiftly accelerate the ship to a relativistic speed when a highly helpful phenomena would occur: time dilation. The passage of time aboard the spaceship would slow as it approaches the speed of light. This physics quirk was popularized in the twin paradox, and in this relativistic rocket, you are the twin who flies away and never ages. On the outside, the clock would still be running, so you could go to Proxima Centauri in 4.3 years, but it would only feel like 3.6 years on board the spaceship. If you wanted to go to Vega, 27 light-years away, it would feel like 6.6 years has passed. The more you travel, the closer you reach the speed of light, and more slowly time passes. With this, you could travel to the core of the Milky Way in 20 years, or to the Andromeda Galaxy at almost 2 million light-years away in just 28 years. However, back on Earth, 2 million years would have passed. But is there a limit on how far we can go? Yes. The cosmos is growing, and it is accelerating. The distance between galaxies becomes wider and wider with each passing second, and the greater the distance between two things in the cosmos, the faster they appear to withdraw from each other. There are galaxies visible in the sky that we can no longer reach, since the only way to get there would be to travel faster than the speed of light to compensate for the universe's rapid expansion. This boundary is known as the cosmic horizon, and its exact size is determined by the right cosmological formula for describing the universe, which is now being constructed. Still, it is imaginable to achieve this limit within a few decades. So, why do we not have a rocket like this? The explanation is, of course, gasoline or fuel power. To maintain such a consistent acceleration, a massive amount of fuel would be required. Even if you imagine an incredibly efficient response, it would be like bringing a planet's worth of gasoline with you. We could theoretically reach any place in the universe that a photon released today could reach if we were to never run out of thrust. Just keep in mind that if you travel far enough, mankind, life on Earth, and even the Sun would all be extinct by the time you could return. But, in the end, the trip is the most essential part of the tale. The video's moral is that space travel as we presently understand it is complex. We face several problems, whether they are technological, physical, physiological, psychological, or ethical in nature. It is possible that how we approach them will make all the difference. So, what do you guys think? Could we see ourselves advancing in the technological sector and make even more advanced rockets and machines? Could we possibly enable and operate warp drive, making us a much more advanced civilization and travel throughout interstellar space? Let us know your thoughts on this in the comments section below. If you enjoyed our video today, please be sure to click the like button, then share and subscribe to our channel for more interesting content just like this. We will see you in the next video.